Okay, welcome 5th graders to the mixtures video test review. Hopefully you have your notebooks out, open, and you're ready to do some science. Okay, stay focused. Here we go. Okay, first of all you need to know what a mixture is. Okay, a mixture is a physical combination. Physical just means you can taste, touch, see, and feel it. Okay, it's hard. You can see it. You can touch it. Okay, you can. Yeah, it's physical, alright? Combination just means it's made up of more than one thing, okay? So it's a physical combination of two or more substances, okay? Like Trix, or Cheerios, or Fruit Loops, or milk, or salad dressing, or orange juice. These are all examples of mixtures, okay? Now, there's a little distinction here, though. If you cannot see the individual pieces that make up that mixture, like milk and orange juice, then it's a solution. You can see the picture here. You can't really see, even though it's made up of a physical combination of two or more substances. These are so small, okay, they're like the size of atoms, each individual piece, that when you look at it, it all looks the same. This is called a solution, okay? If the particles in a mixture is the same size of atoms or molecules, it's called a solution, okay? You cannot see the individual pieces, okay? A solution this is still a mixture though, because it's made up of two or more different kinds of substances, but it's a solution in the sense that you cannot see the individual pieces that make up that solution, okay? If you can see the individual pieces that make up that mixture, then it's just called a mixture. It's not called a solution, okay? So just keep that in mind. Now, let's say I have a mixture and I want to separate the two substances. I want to take the metal out of the sand. I want to take the dust particles off of the rocks. But it would be way too hard for me to try to do that by hand. Do I want to try to remove the spaghetti out of the water? No, I don't want to have to do that. You don't see your parents pulling the spaghetti out of the water, okay? So when it's too hard to do it on your own, using your own hands, there are some ways that you can separate mixtures. We're going to go over 4 of those, all right? There's suspension, okay? Basically, after a while, when you set a substance down, when you set a mixture down, you're going to have some of the substances rise to the top, and you're going to have some of the substances settle at the bottom, okay? So once again, like oil and water, or the example we used in class was salad dressing. You shake the salad dressing up, and it looks like it's all mixed up. Okay, you can see the picture here. It's all shook up. I set it down. After a while, the oil and the water are going to suspend or rise to the top, and all of the spices and herbs that make up the salad dressing are going to sink to the bottom. This is called suspension. You can see in your drawing, after a while, the blue will suspend or rise to the top, and the red will sink down to the bottom. Okay? Here's just kind of the definition you have in your book. A mixture whose particles settle and separate within a few hours. So you can see the red settled at the bottom, and the blue will be suspended to the top. All right? Here's another way that you can separate mixtures. Let's say you have a bowl full of rocks, and those rocks have a whole bunch of dust all over it. You're like, man, how do I get the dust off the rocks? What you can do is you can pour water into that bowl, okay? The water will cause the dust to float to the top, and because the rocks are too heavy, they will sink to the bottom. So that's called flotation. You're separating the dust from the rocks by floating the dust to the top, and the rocks will stay at the bottom. Right? The third way to separate is by filtration. Okay? And this is what we talked about when your parents are trying to separate the spaghetti from the water. They pour the spaghetti with the water into this device called a strainer. Okay? The water goes through the small holes, and the spaghetti, because it's bigger, will not go through those small holes, and it'll stay in the bowl. Okay? Here's the definition that you have in your notebook. Filtration separates substances that have particles of different sizes. So the water is a different size than the big spaghetti and meatballs that you have in the plastic bowl, okay, in the strainer, all right? So the water goes through, because it's a different size, it's small enough to fit through the tiny holes, where the spaghetti is a different size, it's too big to fit through the tiny holes. And the last one I don't think I've mentioned is magnetism. I don't want to have to go through and separate the metal out of a shallow, if there's a plate full of shallow sand, I don't want to have to go through and separate all the little metal pieces. So what I can do is just take a magnet and rub it all over the plate that has the sand in it, and all the metal pieces will start getting attracted to the magnet. When I remove the magnet, all of the metal pieces will go with it. Now I'm left only with the sand. Okay? And I have the little metal pieces all stuck onto my magnet if I wanted to use those later. Alright? So the way that I separated the metal pieces from the sand is by using magnetism. Alright? So those are the 4 ways that you can separate mixtures. Let's dive into a little bit about solutions. Okay? Once again, we talked about solutions. If you look at a solution, it all looks the same. And the individual pieces that make up that solution are the size of atoms. They're really small. You can't see each individual piece. Okay? It's called a solution. There's 2 parts that make up every solution. There is the solvent and the solute. Okay? The solvent does the dissolving, and the solute is the thing that gets dissolved. For example, the example we used in class was beach water, okay, which is made up of salt and water. The water is what dissolved the salt, so it is the solvent. The solute is the salt because that is what got dissolved, right? So keep that in mind. 2 parts to every solution is the solvent, which on our example was the water because it did the dissolving or the soaking up of the salt. And the solute is the salt because it is the thing that got soaked up. Right? So keep those things in mind. All solutions are homogeneous. There's 2 kinds of solutions. You can have a homogeneous one or a heterogeneous one. A homogeneous one looks all the same. And all solutions are going to be homogeneous because they all look the same because the individual particles, once again, are the size of atoms. You can't see each individual piece. Okay, so it's going to be all solutions are homogeneous. They all look the same. Heterogeneous are mixtures that do not look the same. You can see each individual piece is different. Like Fruit Loops is a good one, or Lucky Charms. You have marshmallows, and then you have the little graham cracker things. You have Trix. You have the little yellow bananas in there with the little purple grapes. Those are different. They look different. The color's different. The shape's different. So that's going to be a heterogeneous mixture. A homogeneous mixture, besides like milk and orange juice, because it all looks the same, and the particles are the size of atoms. Another example would be like Cheerios. That's a homogeneous mixture. Although it's not a solution, it is homogeneous because every one of those little O's looks the same. Okay, so once again, this is what you are going to need to know for the mixture test review. Hopefully you watch this a couple times and it starts to make better sense to you. Remember, this is just the first time we're going to be going through this content. We are going to be diving into some of this a little bit later with experiments and that sort of thing. But hope you're enjoying it for this time. Hopefully the test review helps, and I look forward to seeing you in class. I don't know why I ended all dorky right there.